Welcome back to another video by Chemical Engineering Life. In this video, we are going to jump into the top 5 challenges facing chemical engineers in the 21st century and how they can solve them. So do watch the video till the very end, and if you do like it, then remember to like, share, and subscribe to Chemical Engineering Life channel for more videos. Let's begin. The very first challenge that we have for chemical engineers is the global health and biotechnology integration. The recent pandemic has highlighted the critical role of chemical engineers in global health, particularly in the mass production of vaccines, diagnostics, and medical supplies. As biotechnology continues to evolve, chemical engineers are needed to scale up the production of biopharmaceuticals, develop efficient purification processes, and ensure regulatory. Chemical engineers apply principles of reaction kinetics, mass transfer, and thermodynamics to design and optimize cell cultures, fermentation processes, and bioreactors. Chemical engineers' ability to design scalable, cost-effective, and robust systems makes them indispensable in translating the lab-scale innovations into real-world healthcare solutions. So, what's next for chemical engineers? Well, the question is, how can chemical engineers continue pushing the boundaries of health tech while still ensuring access and affordability? The challenge that we have at number 4 is digitalization and Industry 4.0. The integration of digital technologies like artificial intelligence, machine learning, and big data analytics is revolutionizing the chemical process industries. For chemical engineers, this digital transformation means rethinking how processes are monitored, controlled, and optimized. Instead of relying solely on manual measurements and heuristics, chemical engineers can now use predictive models and real-time data to improve efficiency, reduce downtime, and enhance safety. However, the transition isn't seamless because it requires a blend of domain expertise and digital fluency. Chemical engineers must now learn to work with data scientists and IT professionals, adapt to new software tools, and also understand the cyber-physical systems. By doing so, they can bridge the gap between process understanding and digital innovation, driving smarter and more responsive manufacturing systems. So the question that lies ahead of us is obviously, will the next generation of chemical engineers be equipped with the coding and data skills needed to fully leverage these digital tools? The challenge that we have at number 3 is the water scarcity and waste management. With population growth and industrial expansion, access to clean water is becoming a critical concern. Already today, chemical engineers are at the forefront of solving this challenge by contributing solutions through advanced water purification technologies. They are also developing closed-loop systems that recycle industrial wastewater, making operations more sustainable. On the waste management front, chemical engineers are working to reduce, reuse, and recycle waste, and especially industrial byproducts. This includes designing biodegradable plastics, improving plastic recycling methods through chemical recycling, and treating hazardous waste more efficiently. Their expertise in separation processes, reaction engineering, and material science enables them to tackle these multifaceted problems from both environment and economic perspectives. So the question that lies in front of us is, can we make these advanced water and water waste solutions affordable enough for widespread adoption in developing regions? The challenge that we have at number 2 is energy transition and decarbonization. The global shift from fossil fuels to low carbon and renewable energy sources represents a monumental challenge and also an opportunity for chemical engineers. From the production of green hydrogen via electrolysis to the development of advanced battery materials for electric vehicles, chemical engineers are at the heart of the energy transition. One of the biggest hurdles in this industry is scalability. Technologies like hydrogen fuel cells or carbon neutral fuels need to be produced at scale while still keeping cost competitive and safety high. Chemical engineers must innovate at every stage from reaction engineering to catalysis and system integration to drive the transition forward. But the question that lies ahead for chemical engineers is, will the chemical engineers be able to overcome the economic barriers to make renewable energy truly dominant worldwide? And the challenge that we have at number 1 is none other than climate change and sustainability. Climate change is arguably the most urgent global issue of our time, and chemical engineers are uniquely positioned to address it. The production of chemicals, fuels, and materials is energy intensive and contributes significantly to greenhouse gas emissions. As such, chemical engineers must design processes that are cleaner, more energy efficient, and generate fewer emissions. This involves innovations in green chemistry, carbon capture and storage, and the development of sustainable feedstocks. Moreover, chemical engineers play a crucial role in creating circular economies where waste is minimized and materials are reused or recycled, thereby reducing the need for newer resources. But the main question that lies ahead for them is, how can we scale these sustainable innovations without driving up costs or reducing product performance? So these were the top 5 challenges and the main question that lies ahead for chemical engineers. So if you agree or disagree, then do tell us in the comments below. And also, do not forget to learn more about chemical engineering life at our website at www.ChemEnggLife.com. And remember to like, share, and subscribe to ChemEnggLife channel for more videos. Thank you and have a great day.